Breathe in slowly and let your attention widen. Imagine yourself not as a single life on a single shore, but as a point of awareness floating in a vast ocean of light. Tonight we begin at the moment we all share, now, the present of the universe, a living, humming tapestry of matter, energy, and time. From this quiet present, we will travel outward and forward. But first, we must learn to listen to the world as it is. Stars singing in their steady voices, galaxies drifting like islands in a dark sea, and 1,000 small and large processes folding themselves into the moment you inhabit. Look up in your mind's eye and see the Milky Way arching across a night sky, a pale river of stars. That band is not decoration, it's a cross-section of our cosmic neighborhood, a flattened disk of hundreds of billions of stars swirling around a dense, secretive center. Our own sun is one ordinary star among those hundreds of billions, a middle-aged yellow dwarf warming a single rocky world with oceans and breath. The sun's light is a miracle of nuclear alchemy. Deep in its core, hydrogen atoms fuse into helium, and in the alchemy of fusion, they release photons, packets of light that take tens of thousands of years to escape the hot interior, but only 8 minutes to cross the distance to Earth. That steady stream of light is not merely illumination. It is the engine of life on our world, the slow cadence of day and night that sculpts ecosystems, sleep rhythms, and the chemistry of living cells. Yet the sun is not the whole story. All around us, in our galaxy and beyond, stars are being born and dying in a continuous loop. In the dark, cold clouds of gas and dust called nebulae, gravity gathers wisps into denser knots. Over hundreds of thousands of years, these knots collapse and ignite, birthing new stars. The Orion Nebula, visible even to the unaided eye under a clear, dark sky, is one of those star nurseries, a luminous cradle where young stars light the surrounding gas and push away dust with fierce winds. Nearby, older stars will end their lives in different ways. Some swell into red giants and shed their outer layers gently, painting the cosmos with shells of glowing gas and seeding the interstellar medium with elements. Others explode as supernovae, brilliant catastrophic deaths that outshine entire galaxies for a short time. Those explosions forge heavier elements, carbon, nitrogen, oxygen, iron, the raw materials of planets, oceans, and life itself. In this way, the atoms that make up your body were once inside ancient stars. You are literally material returned from cosmic furnaces.
Stretch your mind outward a little further and picture the large-scale architecture of the universe. Not a random scatter, but a cosmic web. Galaxies collect along filaments of dark matter, unseen scaffolding that makes up most of the universe's mass, while vast voids yaw between them. Each galaxy is a small city of stars where gravity has woven matter into structure. Spiral arms swirling with gas and nascent stars, compact bulges dense with ancient suns, and halos of faint stars and star clusters. Our galaxy, the Milky Way, is itself bound in a slow dance with its neighbor, the Andromeda Galaxy. In a few billion years, these two giants will meet in a majestic collision, not a fiery explosion, but a slow, gravitational embracing that will rearrange stars and awaken fresh waves of star formation. The universe is not static, it is an orchestra of motion, each movement rooted in gravity's patient pull. As we hold the present in our minds, remember that the universe is both immensely vast and intimately connected. Look at the small planets, moons, comets, and asteroids, rocky worlds and icy bodies that orbit stars. In the last few decades, telescopes have revealed that planets are common around stars. We now know of thousands of exoplanets, worlds with climates, sizes, and chemistries far different from our own. Some hug their suns with molten skies. Others drift cold and distant, cloaked in ice. A precious few fall into what we call the habitable zone, a range where liquid water could exist on the surface if conditions are right. These habitable worlds have become the new frontiers of our curiosity and hope. But for all their diversity, planets are only one expression of the present. Many more processes, magnetic storms, auroras rippling at the poles, dim flickers of distant quasars, all make up the living moment of the cosmos. Turn now to the watchers, the instruments we've built to listen and see. The present is not merely an external stage, it is a story we are learning to read. From the first lenses of Galileo to the giant mirrors of modern telescopes, humanity has learned to extend its senses. Space telescopes lift us above Earth's atmosphere for a clearer view. The Hubble Space Telescope gave us deep, astonishing pictures of galaxies and star-forming regions. Its images teach patience and scale. More recently, another eye, the James Webb Space Telescope, peers into longer wavelengths, revealing the warm glow of newborn stars and the faint atmospheres of exoplanets. Radio arrays, like the square-kilometer-scale detectors scattered across deserts, listen to the whispers of the cosmos. Pulsars ticking with atomic precision, cold hydrogen fields tracing galaxy structure, and the faint background hum left over from the universe's birth. Each instrument adds a layer to our understanding of the present. Each data point is a note in the continuing song of existence. And here in our present, technology reaches beyond mere seeing. We have sent metallic ambassadors on long, lonely journeys, Voyager 1 and 2, which now drift in interstellar space carrying the golden records. Phonograph messages of our music, voices, and images cast into the dark in the hope that someone or something might someday read them. Closer to home, probes have entered atmospheres, sampled cometary dust, and landed on other worlds. Rovers that trundle across Martian plains with patient curiosity. Orbiters that map the gravity of distant moons, and landers that taste the chemical soups of alien soils. These metal explorers are our present tense reaching outward, experiments in living across distance, and they embody a humility, our desire to know without yet assuming dominion.
In the present also lives a paradox. We are both children of the universe and its latecomers. For most of cosmic history, billions of years, there were no observers at all. Stars burned, galaxies collided, and matter arranged itself without witness. Now, briefly, pockets of consciousness have arisen to ask about their origins. That awareness is fragile and astonishing. The same atoms that make up planets and stars have assembled into life and then into minds that can reflect on themselves.
The physics that describes the expansion of the cosmos and the biology that describes cells are not separate tales. They are chapters of the same narrative woven together. The constraints that made life possible, the strengths of forces, the abundances of elements, are part of the present's deep architecture. We live in the only known pocket of the universe that translates hydrogen, helium, and stardust into music and mathematics, into gardens and stories. That is a privilege heavy with responsibility and wonder. Yet the present also sits upon mysteries. Dark matter and dark energy are invisible actors shaping this moment. Dark matter's gravity gathers galaxies into filaments and keeps them from flying apart. Dark energy pushes the cosmic expansion to accelerate, making distant galaxies recede ever faster. We do not know the nature of these substances. We name them because we observe their effects. In that naming resides our humility. Even now, with telescopes and equations, large parts of the present remain unreadable. The universe gives signals and puzzles in equal measure, and each solved puzzle opens another. A ladder of knowledge where every rung reached reveals a higher mystery. Hold a quiet thought for Earth itself, our tiny blue world, spinning in the present with life in abundance. From space, it appears fragile, wrapped in a thin veil of atmosphere. That atmosphere breathes with cycles, the weather, the seasons, the ocean's tides. Life has co-evolved with these cycles for billions of years, nudging and being nudged by geologic processes. Plate tectonics, lifting mountains, volcanic eruptions, fertilizing seas, photosynthetic organisms pumping oxygen into the air. The present state of Earth, its climate, biodiversity, and human culture is the result of an intricate balance maintained by countless feedbacks. It is not static. It is an active, living weave that hums its scales from microbes to continents. Our choices at this present moment ripple through this web, altering trajectories that will echo far into the future. Now, imagine listening to the universe in silence. There are sounds you cannot hear. The long-period gravitational waves from merging black holes, the faint hiss of the cosmic microwave background, the afterglow of the Big Bang stretched into microwaves by the expansion of space. These relics tell a secret about the present. We live in a universe that remembers its past and records it in subtle tones. Telescopes reading those tones reveal that the cosmos began in a hot, dense state and cooled into the galaxies we now see. That cosmic memory is a reminder that the present carries deep history, stacked layers of events that made this moment possible. In the quiet of your room, let that historical depth settle like a blanket. Think of the present not simply as a point in time, but as the convergence of ancient processes and immediate choices. The last breath of a dying star scattering iron into a cloud that will one day become a planet. The slow drift of continents reshaping climates. The spark of curiosity that sends a probe out to taste an alien world. The quiet decision of a human mind to read, to listen, to wonder. Each of these threads ties us into the living fabric of the present. And finally, let your imagination rest on the ethical light that glows within the present. To observe the universe as it is, alive with matter, motion, potential, and mystery, invites not only curiosity, but care. If the cosmos is generous enough to have given rise to minds, then those minds inherit a duty to steward knowledge, to preserve beauty, to act with prudence. The present is an opportunity. It is the only moment we can act in, the only place where our choices reshape the arc of history. Whether we send machines to the stars, dig cities into the soil, or learn to live in gentler balance with the planet, these acts all begin here, now, in this present that is both ordinary and miraculous. As your breath slows and your body mutes into rest, keep one image with you: the night sky above a quiet field, a pale strip of the Milky Way slicing across it, and the smallness of your village or city beneath, but also the sense that in that smallness lies the universe's capacity to notice itself. The present is a living room of the cosmos. Our species sits there for only a fleeting visit. Listen to the constancy of the stars, the hush of galaxies drifting apart, the soft chemistry of life unfolding. Hold the present gently, like a fragile vessel of light. Soon we will move forward in time to examine how stars will change, how galaxies will evolve, and ultimately how the cosmos itself might wind down. But for now, rest in this living now. The hum of fusion in the sun, the whisper of interstellar clouds, the patient glow of distant galaxies, all converging into the dim, luminous moment you call the present. Sleep, and in that sleep, let the universe keep you company.
Breathe slowly, and let your mind follow the slow arc of time. Not years or decades, but epochs that stretch far beyond your life, far beyond the span of human history. This part of our journey travels forward into the quiet, graceful process by which stars and galaxies age, change, and finally fade. The universe you know, lights scattered across velvet nights, the Milky Way bright across the sky, is a living, transient thing. Stars are being born now, and stars are dying now. The story of their endings is as gentle and inevitable as a winter fire going out, and as luminous and violent as a nova lighting a dark horizon. Let us walk through that long, slow decline together. First, hold a single star in your mind, our sun. It is a modest, middle-aged star, about 4.5 billion years into a life that will last about 10 billion years. Like all stars, it is a furnace held in balance between gravity, which squeezes, and the pressure from nuclear fusion in its core, which pushes outward. Over the long run, the sun and stars like it slowly convert hydrogen into helium in their cores. When the hydrogen is exhausted, the star's inner life changes. The core contracts, the outer layers expand. Our sun will swell into a red giant, a calm and enormous form that will swallow the inner planets, or at least transform them beyond recognition. And then it will shed its outer skin in layers of glowing gas called a planetary nebula, leaving behind a white dwarf, a hot, Earth-sized ember of carbon and oxygen, cooling over eons. This sequence, the gentle ballooning and the peaceful fading, is the typical fate for low and medium mass stars. Not all stars choose the gentle path. Massive stars, those many times the sun's mass, live fast and die young. Their intense fusion creates heavier and heavier elements in nested shells, and when iron accumulates in the core, fusion no longer yields energy to oppose gravity. The core collapses catastrophically, and in a heartbeat of cosmic time, the star explodes as a supernova,
an event that can illuminate a galaxy for weeks. Those explosions are both destruction and creation. They scatter the heavy elements forged in the star's heart into space. Iron, gold, uranium, the elements that seed planets and life, are made and flung into interstellar space by these titanic deaths. Sometimes the collapsing core forms a dense neutron star, a city-sized object of neutrons spinning rapidly, with magnetic fields so intense that they fling beams of radiation across the cosmos. Other times, gravity wins entirely, and a black hole is born, a region where space is curved so drastically that not even light escapes.
Now imagine the balance of births and deaths across entire galaxies. For the first several billion years after the Big Bang, the universe was full of gas and dust, and star formation ran hot. Galaxies were nurseries, lighting the darkness with young blue stars and fireworks of growth. But the present is not that peak. Cosmologists have charted the universe's star-making history and found a rise and fall. Star formation rates climbed to a crescendo some 10 billion years ago and have declined ever since. Over cosmic time, the raw material for new stars, the cold molecular gas, becomes used up or heated and dispersed. Supernovae and active supermassive black holes at galaxy centers can drive winds that push gas out of galaxies. Galaxies merge, their gas shocked and stirred, and the processes that once ignited bursts of star formation eventually peter out. In time, stars are born more slowly than they die. The light of youth gives way to the long, soft glow of aging stellar populations. As star formation slows, the lives of galaxies themselves change. Spirals like our Milky Way, with their graceful arms and ongoing star birth, will gradually exhaust their reservoirs of star-forming gas or have it heated beyond use. Some galaxies undergo violent mergers that shuffle stars and gas into spheroidal shapes. These collisions can trigger brief periods of frenzied star birth, but often end with an aging red population dominated by old, low-mass stars. Over immense timescales, the grand island universes we call galaxies will merge into larger, slower systems. Astronomers predict that in some billions of years, the Milky Way and Andromeda will meet and coalesce into a single giant, sometimes playfully called Milky Meta, a new galaxy whose star formation will be altered irreversibly by the mixing of gas, star clusters, and central black holes. Look now at the long tail of stellar populations. The universe's luminous stage will increasingly be dominated by low-mass red dwarf stars, the quiet, economical workers of the cosmos. Red dwarfs burn their fuel so slowly that they can persist for trillions of years, orders of magnitude longer than our sun. In the far future, when the bright, massive stars have flickered out, these long-lived dwarfs will be the last steady lights of the galaxies, small and faint, but persistent. Planets around such stars, if present, could host enduring warmth for unimaginably long stretches of time. Brown dwarfs, failed stars that never ignited full hydrogen fusion, fade into cold embers, and white dwarfs, the remnants of sun-like stars, slowly radiate away their heat, becoming black dwarfs after unimaginably long cooling times. The universe becomes a quieter place, punctuated by slow embers instead of roaring furnaces. Between now and that gentle twilight, dramatic events will still occur, though at ever-decreasing rates. Stellar collisions and rare mergers continue to create sporadic bursts of light. White dwarfs accreting matter from companions can explode as Type A supernovae, events that temporarily light up entire galaxies again.
Binary neutron stars may merge, producing short, brilliant flashes of gamma rays and forging heavy elements in furious R-process nucleosynthesis. But these events become rarer as the fuel runs low and orbits are emptied by the slow, steady dynamical evolution of star systems. Galaxy centers, those places where supermassive black holes lurk, will continue to eat stars and gas when available, occasionally flaring as active nuclei. But over epochs, even these feasts thin out.
A deeper and stranger force shapes the end of galaxies more than any single star: dark energy. This mysterious component of the cosmos acts like a gentle pressure that accelerates the expansion of space. As the universe ages, galaxies, not gravitationally bound to us, will recede ever faster, slipping beyond a cosmic horizon so they can no longer be seen or reached. The observable universe will shrink, in a sense. Distant galaxies disappear from our sight as expansion outruns light's ability to cross the growing gap. In the far future, the only significant structures remaining within any given observer's reach will be the gravitationally bound group of galaxies that merged into a single island. For us, that destiny looks like a lonely future where our merged Milky Way Andromeda neighborhood glows softly amid an ever-darkening backdrop. The cosmos becomes a series of islands in an expanding sea. Think also of the long-term fate of planets and the fragile places where life might live. Planetary systems are not forever fixed. Over extremely long timescales, interactions between stars, gravitational nudges during galactic mergers, and the steady tug of passing objects can destabilize orbits. Planets can be ejected into interstellar space as rogue planets, wandering cold and dark. Those that remain may be warmed briefly by stellar encounters or catastrophic events, but in the end, planetary habitability dwindles as starlight grows scarce and radiation events carve away atmospheres. Even our sun will, in its red giant phase, transform the inner solar system. The scenes of planetary life are ephemeral movies upon the greater cosmic stage. Now imagine the great milestones of cosmic eras compressed into a slow, measured list. Cosmologists often parcel the universe's future into named epochs. We are now in the stelliferous era, the age of stars, where nuclear fusion lights the heavens. This era will endure for a very long time, billions to trillions of years, but it is not permanent. After it ends, the universe will pass into the degenerate era, a time dominated by stellar remnants, white dwarfs, neutron stars, and black holes. Over even longer stretches, the black hole era will dominate, where black holes, the last dense objects, slowly evaporate through Hawking radiation, releasing faint quanta of energy over stupendously long timescales. Finally, the dark era lies beyond that, a time of almost complete darkness where only low-energy particles and radiation wander and structure as we know it dissolves. These labels help us imagine the flow of cosmic history, but they are rough guideposts. The details depend on physical constants, as yet unproven ideas about particle stability, and the ultimate behavior of dark energy. There are speculative variables that could change the narrative. If protons, the building blocks of ordinary matter, slowly decay over fantastically long timescales, then baryonic matter itself might disappear, erasing planets and stars ultimately. If dark energy varies with time, accelerating more strongly or relaxing, the fate of galaxies and their lights could be quite different. For now, the most conservative picture accepted by many cosmologists is that the universe will head toward a colder, darker state, dominated by remnants and the slow evaporation of black holes, but with room for debate and surprise. Even as the last ordinary lights fade, the cosmic story remains beautiful.
Think of the supernovae that made the iron in your blood and the gold in a ring. Brilliant, final acts that turned the cores of stars into the atoms of planets. Think of the slow, patient red dwarfs glowing for trillions of years, offering steady companionship to distant civilizations that might arise in those remote epochs. Think of black holes, once feared as annihilators, now the universe's slow radiators, quietly releasing their mass back as faint quanta over timescales so immense they boggle the mind. The end of stars is not a sudden vanishing, but a long, elegant diminuendo, a gradual thinning of brightness where the universe exhales and rests. As you lie in the stillness, allow the image of the universe's slow closure to cradle you. Picture galaxies gently coalescing, stars flickering like the last embers of a great hearth, and a quiet where the din of starbirth is replaced by the hush of cooling remnants. This end is not bleakness alone. It is a transformation, a final composition in which the elements of the cosmos return to simpler forms, letting entropy weave the last verses of a long song. In that song, the materials of life and thought have already been composed and scattered, and the memory of their light will shimmer in the cosmic background for eons. Soon we will go onward, deeper still into the next acts of cosmic time, where white dwarfs cool, black holes grow and fade, and the very notion of what remains will be asked again. But for now, rest with the image of the star's slow wane, a universe that has given itself to light and then to quiet, and in that rhythm, a strange and gentle consolation. Sleep now, and let the galaxy's soft decline lull you into a deep and patient rest.
The stars have faded. The grand galaxies that once danced across the cosmic stage now drift apart in silence, their light extinguished, their dust dispersed. What remains of the universe at this unimaginable distance into the future are the ancient relics of gravity, black holes, the final monarchs of a fading cosmos. Welcome to the black hole era, a time when light itself has nearly vanished, and the universe belongs to shadows. Billions upon billions of years have passed since the last star burned out. The universe has grown cold and vast, expanding endlessly under the quiet hand of dark energy. Once, galaxies shone like cities in the night, connected by glowing bridges of gas and starlight. Now those cities are ruins, faint smudges of dead matter orbiting invisible centers of gravity. Everything that once glimmered has been swallowed by time or drawn into the unfathomable grip of black holes. In this era, black holes are not mere phenomena. They are the rulers of existence. These cosmic abysses, formed from the collapse of the heaviest stars, now drift through darkness, devouring what little remains. Planets, asteroids, rogue stars, and even entire stellar corpses spiral toward them, falling silently beyond their event horizons. Inside, matter is crushed into singularities, points so dense that even the concept of space and time ceases to make sense. But even here, there is activity.
Though the universe seems lifeless, these black holes are far from dormant. Each one is a cosmic engine, spinning, radiating faint energy through Hawking radiation, a phenomenon first proposed by physicist Stephen Hawking in 1974. According to his theory, quantum effects at the edge of the event horizon allow black holes to slowly lose mass, particle by particle, evaporating over unimaginable spans of time. For the largest supermassive black holes, this process will take 10 to the power 100 years, a number so vast it defies comprehension. Yet, it means even these cosmic titans are not immortal. Imagine it, a universe in which black holes begin to die. As they evaporate, they release bursts of radiation, tiny flares in the eternal night. These brief moments, lasting perhaps seconds, will be the final fireworks of the cosmos. The evaporation of a black hole the size of a mountain could unleash more energy in an instant than all the stars of the Milky Way emitted during their lifetime. And yet, there will be no one to witness it. No eyes to see, no minds to understand. The small black holes, perhaps created in the early universe, are already gone. They evaporated long ago, releasing their final flashes of light. The medium-sized ones, formed from dead stars, are now slowly fading, glowing faintly in the microwave wavelengths of radiation. And far in the depths of time, only the supermassive black holes remain, the giants that once anchored galaxies. Some contain the mass of billions of suns. They sit in cosmic silence, their gravitational influence stretching across what was once entire galactic clusters.
Over time, even these titans will weaken. They'll emit more Hawking radiation than they absorb, shrinking gradually until they too begin to tremble with quantum fury. Their surfaces will flicker, their mass will drain away, and at the end, in a brilliant final instant, they'll explode into a burst of pure energy, the last light ever to shine in the universe. This will mark the end of structure. With the death of the last black hole, no objects of complexity will remain. No stars, no planets, no black holes. Only subatomic particles drifting in an ever-expanding void. The universe will have entered its final age, the Dark Era, where entropy reigns supreme and nothing ever changes again. But let's pause just for a moment to consider what a black hole truly is. These objects, so feared and so mysterious, may also be the gateways to understanding the universe itself. Inside them lies the breakdown of everything we know, the failure of physics as we understand it. Space, time, matter, all dissolve into an infinite curve of density and gravity. Some theories suggest that the cores of black holes might not be singularities at all, but bridges, wormholes to other regions of space or even other universes. If this is true, then black holes are not the end of everything, but perhaps the beginning of something else entirely. Yet such speculation remains beyond our reach. No information can escape a black hole's grip, not even light. Whatever secrets they hold are locked away behind the event horizon, hidden from the universe forever. And as the cosmos continues to cool and stretch, those secrets will fade into irrelevance. The night will deepen. The fabric of space itself will continue to expand until even black holes, the last great actors of existence, are reduced to whispers of radiation in the void. In the end, only the faint hum of entropy will remain, a universe without structure, without heat, without contrast. The energy once concentrated in blazing stars and swirling galaxies will be spread evenly across an infinite expanse, too diluted to form or fuel anything. This is the ultimate heat death, equilibrium without life, balance without change, silence without end. But perhaps in that infinite dark, something will still stir. Quantum fluctuations, the restless dance of the vacuum, might still flicker for eternity. Tiny blips of energy might appear and vanish in trillionths of a second. Some cosmologists have suggested that given infinite time, one of these fluctuations could randomly create something vast, even another universe. So maybe this is not the end, but merely a transition. The black hole era may be both an ending and a seed, a cosmic chrysalis from which something new might emerge billions of trillions of years from now. As the last black hole fades and its final photon escapes into the cold void, the universe takes one last breath of light. The night deepens, and the stage is set for the next act in the infinite story of existence, the dark era, where time itself begins to lose its meaning.
The stars are gone. The black holes have vanished. The universe, once filled with light and life and motion, has become a silent sea of near-nothingness. This is the dark era, the last age of the cosmos. No galaxies glimmer in the void now, no warmth radiates through the vacuum. All that remains are the faintest whispers of energy, stray photons stretched to unimaginable wavelengths, and ghost-like particles wandering through a space that itself is slowly unraveling. It is difficult for the human mind to grasp such timescales. To reach this era, the universe has aged beyond measure, 10 to the 100 years, perhaps 10 to the 1,000 years, numbers so vast they defy even metaphor. Every proton that once formed the atoms of stars, planets, and people has either decayed or drifted apart. Every structure that once bound the universe together, matter, gravity, even the fabric of space itself, is losing coherence. In this ultimate twilight, there are no forms, no colors, no sounds, only entropy, the quiet ruler of the end. The second law of thermodynamics, which dictates that disorder always increases, has finally fulfilled its prophecy. All usable energy has been spent. Nothing more can happen. The cosmos has achieved perfect equilibrium, and in doing so, it has died. But how did it come to this? To understand, we must first look at the death of matter itself. For eons, physicists believed that protons, the building blocks of atoms, were eternal. But grand unified theories, like those developed in the late 20th century by physicists such as Abdus Salam and Steven Weinberg, suggest that even protons decay, albeit over unimaginable spans of time.
around 10 to the 34 years. If true, then every atom in the universe is doomed. Imagine it. The atoms that once made up oceans, mountains, stars, and people will slowly fall apart, spitting out lighter particles, electrons, neutrinos, and photons until nothing remains but a thin gas of radiation and elementary fragments. These remnants will continue to cool, spreading further apart as the universe's expansion accelerates. Dark energy, the mysterious force discovered at the turn of the 21st century, continues to push galaxies away from one another faster and faster. In the present era, this expansion is gentle. Galaxies drift apart over billions of years. But far into the future, this expansion becomes terrifyingly absolute. Over quadrillions of years, distances between particles grow so vast that they can no longer interact. Eventually, the cosmic horizon, the distance beyond which no information can reach, will shrink so dramatically that each surviving particle is effectively alone. The universe becomes a collection of isolated points, each cut off from the rest by the sheer vastness of expanding space. At this stage, reality is both infinite and empty. The temperature of the universe approaches absolute zero, so close that motion itself nearly ceases. Time still flows, but it loses meaning because nothing changes. Every second is identical to the one before it.
Yet, even this is not the end. Space and time themselves are not eternal backdrops. According to modern cosmology, space-time is dynamic. It bends, stretches, and responds to the presence of energy. As energy fades, space-time itself begins to lose structure. Think of the universe as a vast ocean of quantum fields. When those fields calm to absolute stillness, the ocean no longer ripples. It is as though reality itself begins to fade away. Quantum physics tells us that even empty space is never truly empty. The vacuum seethes with fluctuations, tiny blips of energy that appear and vanish, giving rise to particles for fleeting moments. But as the universe stretches and cools, these fluctuations become weaker, rarer, and eventually cease. The quantum foam at the heart of existence flattens. In this fading reality, time itself becomes uncertain. General relativity and quantum mechanics, the twin pillars of modern physics, no longer provide clear answers. When there is no change, can time be said to pass? When there is no energy, can space even exist? Some physicists, like Roger Penrose, have proposed that this state might not be the end, but the beginning of something new. In his conformal cyclic cosmology, Penrose suggests that when the universe becomes perfectly smooth and cold, when all particles move at the speed of light and mass ceases to exist, the universe loses any meaningful sense of scale. At that moment, the end can be reinterpreted as a new Big Bang, the birth of another universe. In this view, the death of one cosmos is the conception of another. The fading of space-time is not a final silence, but a reset, a cosmic heartbeat that pulses once every eternity. The last whisper of radiation from the dying universe could become the first flash of energy in the next. Other theories are more bleak. Some cosmologists argue that the universe may continue to expand forever, its fabric stretching thinner and thinner until quantum effects tear it apart in a big rip, a final catastrophic acceleration that shreds atoms, space, and even time into meaningless fragments. Others suggest that the vacuum could collapse suddenly in a process known as vacuum decay, where a bubble of true vacuum, a lower energy state of reality, forms spontaneously and expands at the speed of light, rewriting the laws of physics as it consumes the universe. Either way, the final act is incomprehensibly quiet. There will be no explosion, no collapse, no sound. Only the slow dissolution of everything. The geometry of space-time itself, the stage upon which all existence has played out, will flatten into nothingness. And yet, even in this emptiness, something stirs, not in matter, but in imagination. The human mind, which arose briefly from the cosmos to contemplate its own origins, can still project meaning into this vast darkness. We are the universe made self-aware, the fleeting spark of thought that briefly illuminated eternity. Perhaps, in that sense, consciousness is the last survivor, not in physical form, but as a pattern echoed across time. As the fading universe exhales its last quantum breath, we are reminded of our place within it, impossibly small, and yet immeasurably significant for having known it at all. The cosmos does not end with a bang or a blaze of light. It ends with a sigh, a quiet, infinite unraveling into stillness. Space dissolves, time loses direction. The story of everything pauses on the edge of eternity.
When the last traces of light have faded, and the universe itself seems to have exhaled its final breath, a haunting question lingers in the infinite dark. What lies beyond the end? It is a question that no telescope can answer, no equation can prove. And yet, it is the question that defines all others. The story of the cosmos, from the birth of the first atoms to the death of the last star, has always been a cycle of transformation. So perhaps even the death of everything is not truly the end, but another metamorphosis, one that takes place beyond the boundaries of space, time, and comprehension. To imagine what could come after the end, we must journey into realms of speculation that stand at the edge of science, where physics, philosophy, and metaphysics blur together. And yet these ideas are not wild fantasy. They are the result of the deepest human efforts to understand the nature of existence itself, guided by theories from quantum cosmology, thermodynamics, and relativity, and by the oldest intuition of all, that creation never truly ceases. The echo of eternity, cyclic universes. Among the most captivating theories is that of the cyclic universe. This idea is ancient, appearing in Hindu cosmology, the philosophy of the Stoics, and Buddhist teachings, all of which envision time as an endless wheel. Modern science, intriguingly, has found echoes of this in the mathematics of relativity and quantum gravity. In Roger Penrose's Conformal Cyclic Cosmology, or CCC, the universe does not truly end. Instead, when all matter has decayed and the cosmos becomes filled only with massless particles like photons, the very notion of scale ceases to exist. Without scale, there is no distinction between something infinitely large and something infinitely small. In this timeless, featureless universe, the geometry of space wraps around, transforming the end of one universe into the birth of another. In other words, the ashes of one cosmos become the spark of the next. Penrose's theory even makes predictions, suggesting that faint imprints from a previous universe could be detectable in the cosmic microwave background radiation, CMB, the afterglow of the Big Bang. Some cosmologists have claimed to see strange circular patterns in that radiation, ghostly echoes of black holes from a universe before ours. If CCC is correct, then the universe is eternal, not in the sense of lasting forever, but in the sense of repeating endlessly. Countless universes have existed before ours, and countless more will follow, each born from the silence of the last.
Quantum rebirth. The vacuum awakens. Another idea comes from the strange and unpredictable world of quantum field theory. Even in the empty vacuum, there is no true emptiness. The quantum vacuum seethes with potential. Fleeting virtual particles appear and vanish in less than a trillionth of a second. As the universe cools to absolute stillness, quantum uncertainty ensures that it can never be perfectly stable. Even the most quiet vacuum is inherently unstable. Over vast timescales, perhaps 10 to the 100,000th years or more, random fluctuations could once again create a burst of energy so intense that it inflates into a new universe. This is known as the quantum fluctuation model of cosmogenesis, and it suggests that our Big Bang may have been just such an event. What we call the beginning might not have required a creator or a cause, but merely a fluctuation in an eternal quantum sea. In this model, universes are born not from nothing, but from the quantum instability of nothingness itself. Each one may have different physical laws, different constants, dimensions, even different forms of matter. Some die quickly. Others, like ours, expand and bloom into galaxies and life. The multiverse, then, becomes a cosmic garden, infinite and ever regenerating. The multiverse, beyond our horizon. If the universe can give birth to others, then perhaps our cosmos is only one bubble in a vast foam of realities, the multiverse. This idea gained traction through cosmic inflation, proposed by physicist Alan Guth in the 1980s. Inflation describes how in the first fraction of a second after the Big Bang, the universe expanded exponentially. But according to modern extensions of the theory, particularly eternal inflation, proposed by Andre Limb, this process never truly ends. While our universe stopped inflating and cooled, other regions of space kept expanding, spawning new bubble universes endlessly. Each bubble could have its own laws of physics, its own constants, its own stars and galaxies, perhaps even forms of life unrecognizable to us. Some may be barren, others may teem with unimaginable forms of consciousness. In this vast multiverse, our universe is neither unique nor final. It is one brief flicker in an infinite storm of creation. The end of our cosmos, then, is only a local event, the fading of a single bubble while countless others still glow brightly.
The simulation hypothesis, the universe as information. There is, however, a more radical perspective, that reality itself may not be physical at all, but informational. Physicists like John Archibald Wheeler once suggested that the universe might be fundamentally digital, made up not of matter and energy, but of bits of information, it from bit, as he famously phrased it. In this view, everything that exists,
from galaxies to atoms to consciousness, is the result of information being processed. The laws of physics are simply the rules of a cosmic computation. If this is true, then what we perceive as the end of the universe may not be destruction, but the completion of a computation, a grand cosmic program that has run its course. And what happens when one simulation ends? Perhaps another begins, initialized by the same or a higher level reality. This concept resonates eerily with ancient philosophies: Hindu Maya, the illusion of reality; Plato's cave, where shadows are mistaken for truth. Modern thinkers like Nick Bostrom have speculated that advanced civilizations could run entire universes as simulations. If so, we may be living in one, and when our simulation ends, it may give rise to another, in a chain of recursive creations stretching beyond comprehension. Consciousness as the final constant. As physics pushes toward the limits of understanding, a subtle question emerges. Is consciousness merely a product of the universe, or is it somehow fundamental to it? In the anthropic principle, the universe is described as one that must allow for observers like us to exist, meaning the laws of nature are not arbitrary, but tuned for awareness. In more speculative ideas like panpsychism or quantum consciousness, awareness may not arise from the universe, but may be woven into it. If consciousness is fundamental, then even if the physical universe ends, awareness, in some form, might persist, not as human thought, not as memory or personality, but as the pure experience of being, the eternal observer behind all creation and destruction. In that sense, the end of the universe may be like waking from a long dream, a return to a deeper reality that has always been present. The death of the cosmos may simply be the mind of the universe opening its eyes. The final reflection. So what lies beyond the end? Perhaps nothing, a perfect, eternal silence that follows the final heartbeat of time. Or perhaps everything, an endless cycle of births and deaths, like waves rising and falling in the cosmic sea. Maybe our universe is one story among countless others, each with its own beginning and end. And the true universe is the collection of all possible realities. And perhaps, just perhaps, the act of wondering, the fact that consciousness within this fading universe can even ask the question, is itself the answer. Because if the universe is a story, then awareness is its reader. And as long as awareness exists somewhere, somehow, the story never truly ends.
When the last stars have faded and the universe seems to drift into eternal darkness, it feels like an ending beyond all endings. But what if it isn't? What if this death, the collapse of all structure, the cooling of all energy, the silencing of all motion, is not destruction, but the beginning of something new? The idea that the universe could die and be reborn is one of the most profound concepts ever explored by human thought. It is both ancient and modern, as old as the myths of creation and as current as the frontiers of theoretical physics. Across cultures, across centuries, we have always asked the same question in different words. Is existence a straight line, or is it a circle? In this part of our cosmic story, we travel into the realm of cyclical universe theories. the astonishing possibility that time itself may not be a river with a single direction, but a wheel, turning endlessly through creation, destruction, and renewal. The ancient echo of the eternal return. Long before modern physics, the idea of a recurring universe was already alive in the minds of ancient thinkers. In Hindu cosmology, time was not linear but cyclical. The universe, according to the Vedas, passes through vast cosmic epochs called kalpas, each lasting billions of years. Creation and destruction follow one another endlessly. Brahma dreams the universe into existence. It evolves, decays, and is then dissolved, only for a new dream to begin. Similarly, in Buddhist cosmology, countless universes arise and fade, like bubbles on the surface of an infinite ocean. The Stoic philosophers of ancient Greece also believed in a concept known as ekpyrosis, the periodic destruction of the cosmos by fire, followed by its rebirth. Even in Norse mythology, the world ends with Ragnarok, only to rise again from the ashes. These ancient visions were poetic, but they held an intuitive grasp of a truth that physics would one day rediscover, that the universe might be governed not by beginnings and endings, but by eternal cycles.
The Big Bang and the question of before. In the early 20th century, when Albert Einstein formulated general relativity, the idea of a static universe still dominated science. It was the discovery of cosmic expansion by Edwin Hubble in 1929 that revealed the universe was not fixed but evolving, stretching outward from a singular beginning, the Big Bang. But if the universe had a beginning, what came before? Could the Big Bang itself have been the result of a previous universe collapsing? This question gave rise to the first modern cyclic universe theories. One of the earliest, proposed in the 1930s by Richard Tolman, suggested that the universe expands and contracts in endless cycles. In Tolman's model, after billions of years of expansion, gravity eventually overcomes inertia, causing the universe to collapse back into a big crunch. Then, from that compression, a new expansion begins, a new Big Bang. The idea was elegant, but it faced a problem. Each cycle would lose energy through entropy, the inevitable increase of disorder. Over time, each new universe would be larger and colder than the one before, and the cycles would eventually stop. For decades, this heat death seemed to doom the dream of eternal rebirth. But science, like the universe itself, rarely stands still. The quantum bounce. Death is not the end. With the rise of quantum gravity and loop quantum cosmology, a new generation of physicists began to reimagine the end, not as a collapse into nothing, but as a bounce. In loop quantum gravity, space-time is not continuous, but made up of tiny, discrete units, a kind of cosmic fabric woven from quantized threads. At the Planck scale, where density and energy become extreme, gravity itself becomes repulsive. This means that as the universe contracts toward a singularity, instead of collapsing infinitely, it rebounds, producing a big bounce instead of a Big Bang. In this model, the universe never truly begins or ends. It oscillates eternally between expansion and contraction.
birth and death. Each bounce resets the cosmos, erasing its past yet carrying subtle imprints of what came before, quantum echoes of previous cycles. The mathematics of these models come from Abhay Ashtekar, one of the leading figures in quantum gravity. His work shows that the equations of general relativity can be extended beyond the singularity, suggesting that time itself might continue through what we once thought of as the beginning. If true, it would mean that our Big Bang was not the origin of existence, only the latest chapter in an infinite story.
Penrose's conformal cyclic cosmology, universes without beginning or end. Perhaps the most elegant modern version of a cyclic universe is Roger Penrose's conformal cyclic cosmology. Penrose, one of the most brilliant mathematical physicists of our time, proposed that when the universe becomes so vast and empty that all matter has decayed into radiation, scale itself becomes meaningless. In such a universe, there is no longer any difference between something very large and something very small. At that point, Penrose argues the geometry of space-time resets. The infinite cold future of one universe becomes, through a conformal transformation, the fiery birth of the next. In CCC, universes do not collapse, they fade and reignite. One universe's end is another's beginning, seamlessly connected through the mathematics of relativity. And remarkably, Penrose believes there may be observational evidence for this. Faint circular patterns in the cosmic microwave background, possible ripples left by black holes that evaporated in a previous eon. If these claims are verified, it would mean we are literally seeing fingerprints from a universe before our own. String theory and the collision of universes. Another version of a cyclic cosmos comes from string theory, particularly in a model called brane cosmology. In string theory, our universe might be a three-dimensional brane floating in a higher dimensional space, part of a larger multiverse filled with other branes. Occasionally, these branes could collide, releasing enormous energy that manifests as a Big Bang. This idea was explored by Paul Steinhardt and Neil Turok in the ekpyrotic universe model, named after the ancient Stoic idea of cosmic fire. In this theory, universes are born not from quantum fluctuations, but from the rhythmic collisions of higher dimensional membranes. Each impact ignites a new cosmos, and the process continues forever. In this picture, the Big Bang was not a singular creation, but a recurring event in a timeless dance of cosmic dimensions.